Fine. I think we have to start now. Good evening, all of you. I hope all of you are safe, and we have to continue from last class where we have seen how to calculate wind pressure according to IS 875 Part 3 and how to calculate seismic base shear by using IS 1893. And I'm continuing today's class from last class onwards. In the last class, someone have asked doubt about what we have to do. Is there any modification factor we have to use if the structure is in coastal region? A coastal region is nothing but according to IS 875 Part 3, if there is any region within the 200 kilometers radius from the bank of a river or a sea, that can be called as a coastal region, you have to use multiplication factor of 1.15 for that. Okay, I have clarified in the group itself. Just now to make a note, I'm telling you. Okay, and then let's continue today's class. I'm sharing my screen. Just someone is there. Can you mute yourself? Yes, okay. Is my screen visible to all of you?
Yes, sir. Yes.
Yes, okay, fine. Thank you. Thank you very much for your response. Okay, last time, in the last time, we have calculated the wind pressure. From that onwards, I'm continuing this one. Okay, let's see how to calculate wind coefficients. What are these wind coefficients? Generally, in a PEB structure or in a steel structure, we have to apply wind load in several cases. Generally, the wind load will be applied in 8 cases, but in the practical, we have to apply only 6 cases only. So, what are those 6 cases? Let us see. How we cannot apply directly wind load into the surface of the structure. So, we have to use some coefficients. Those coefficients can be called as wind coefficients, and there are some clauses and there are some tables in IS 875 Part 3. So, what are the clauses and tables we'll see now? So, basically, in wind coefficients, there are two types of wind coefficients we'll use. One is external and another one is internal wind coefficients. So external wind coefficient is nothing but a coefficient will be applied from the outside surface of the building. A coefficient, suppose if you see, let us take this as a frame. Okay, so if the coefficient is applied from the outside of the building, that can be called as. If the coefficient is applied from the inside of the building, it can be called as internal wind coefficient. So, in the practical purpose, we use net coefficients. Net coefficients is nothing but the algebraic sum of internal and external coefficients. Okay, for example, let us take external wind coefficients for wall. This is located in table number 5 of IS 875 Part 3. So let's go to IS 875 Part 3, table number 5. Here you can see table number 5, external pressure coefficients for walls only. Okay, for walls of rectangular cladding buildings. Okay, so there are several cases you can see here. So what are these several cases? So from last time onwards, from the last class onwards, we are taking one example. to make sure how the wind coefficient or seismic coefficients are calculated. So I'm using the same example for this session also. So nothing but length of the building is 30 meters, width 20 meters, eave height, nothing but the height from base to the top of the eaves, that is 6 meters, and the roof slope is 1 in 10. Okay, dead load and live load are 0.3 and 0.6 respectively. Okay, base spacing, let us take nothing but the spacing, the center to center distance between two successive frames, that can be called as base spacing. So that is 5 meters each. Okay, 6 numbers of 5 meters center to center spacing make 30 meters length of the building. Like that, I have taken one example. That is the example I'm using here. Okay. So for calculating external wind coefficients, let's go to table number 5. In this table number 5, building height ratio, first parameter we have to use is building height ratio. Nothing but H by W. H by W is, if H by W is less than or equal to 1 by 2, one case. If it is between 1 by 2 and 3 by 2, second case. More than 3 by 2 to 6, third case. There are several cases like that. So for example, I have taken building height as 6 meters, right? Suppose 6 divided by width of the building is nothing but the lateral, shortest lateral dimension, that is 6 by 20, that is 0.3. So 1 by 2 is 0.5. So we have got the value of 0.3. So first case is the applicable for us, right? So in that, again, two categories are there. L by W, length to width ratio, building plan ratio, you can see here heading of the category. So length to width ratio, if it is in between 1 to 1.5, one case, 1.5 to 4, another case. So what is the ratio for us, for our example? Let us see. So width is 20 meters, length is 30 meters. So which one I have to apply here? So length to width ratio. Length is 30 meters divided by width is 20 meters. That gives you 1.5. Yes. Okay. So 1 to 1.5, first case, right? You can see here L by W is in between 1 to 1.5, including 1.5, less than or equal to, you can see equal to symbol is here. So 1 to 1.5, first case. So we have to use this case only. Okay, we have to use this case only. So next, elevation. What is the height of the building, width of the building we have seen. Okay, so in this plan, A surface, B surface, C surface, D surface are there. So what are these surfaces? Suppose A surface, so this is the width of the building. Along the width of the building, two sides, one side is A, one side is B. Suppose, for example, I'm showing you here. So if the frame is like this is A surface, this is B surface. C surface and D surfaces are normal to the surface along the Z direction. Okay, C and D surfaces are normal to the surface, normal to our screen. Suppose let us take normal to screen, that is perpendicular to the screen. Okay, that is Z axis. So this one is A surface, this one is B. C and D are perpendicular to the screen. Okay, so A surface and B surface. There are two types of winds: 0-degree wind, lateral wind. So generally in the practical, wind can act along any direction, right? So if it acts along the x-axis, one coefficient will be there. If it acts along the z direction, one coefficient will be there. So sir, you'll get doubts. Sir, what about y direction? So we will not, this is only for walls, right? We will not apply y direction on walls. We have to apply y direction on roofs only, right? So this table is for only walls, right? So we are talking about X direction and Z direction. So 0-degree wind is nothing but direction of the wind along X direction. 90-degree wind is nothing but direction of the wind along Z direction. Okay. For example, 0-degree wind. Okay. If the wind goes from left to right, first of all, let us see surface A. For 0-degree wind, what is the external coefficient here? You can see plus 0.7. Okay, plus 0.7 for 0-degree wind along the surface A. Okay, I told you this as the surface A, this as the surface B. So along the surface A, we have to use plus 0.7. So obviously you will get one doubt. Sir, what is this plus symbol and what is this minus symbol? Okay, so this plus symbol denotes any wind coefficient towards the surface of the building. Okay, this is external towards the surface of the building, right? So in this direction, okay, along positive X direction, in this direction it is 0.7, right? Plus is nothing but towards the surface, minus is nothing but away from the surface. Okay, I'm again telling you, plus is nothing but towards the surface, minus is nothing but away from the surface. Okay, so obviously for surface B is nothing but 0.7. First case we have seen first. This is surface B. Okay, this is surface B. Only walls we are seeing now. We are not talking about roofs. Okay, for only walls, A surface is 0.7. B surface is what about B surface? B surface is minus 0.2. Okay, let us see this as minus 0.2. Okay. So okay, first we have completed 0-degree wind. Okay, here you can see we have completed 0-degree wind for A and B surface. What are these C and D surfaces? C and D surfaces are nothing but the coefficients which we have to apply along the end wall frames only, nothing but on the end wall columns. Okay, so we'll see these coefficients later. First of all, let's complete one main frame. We are completing coefficients for one main frame which is in enclosed condition. These are not for open condition or partial enclosed condition. These are for enclosed conditions. Okay, so for 90-degree wind, if the wind acts in this direction, okay, if the wind apply along C and D direction, there will be some pressure on A and B also, right? Not only if the wind acts in A and B direction, there will be A and B only. If the wind acts in C and D direction also, there will be some pressure exerting on A and B surfaces, right? So for 90-degree wind, we have to use the maximum or critical one we have to take from these two A and B surfaces. Okay, only generally we will use only one case only, but here you can see minus 0.5, minus 0.5, the both are same. Okay, if both are different, we have to use the critical case only. Which one is the critical? Okay, so but here in this case, both are same, minus 0.5, minus 0.5. So I'm taking minus 0.5 here. So, okay. So these are external wall coefficients for external wind wall coefficients. Okay. Okay. I'm getting some disturbance. So, okay, fine. So we have taken external coefficients for walls, right? So what about these internal coefficients? So internal coefficients, we have to use clause number 7.3.2.1. So just have to go for 7321 clause. 7321. This is the 7321 clause. In case of buildings where the claddings permit the flow of air with openings not more than about 5%. Why he has given 5% cushion here? Nothing but generally any building will have certain number of doors and windows for ventilation, right? So he has left that 5%. So okay, except that within that 5% openings are okay. So that can be called generally enclosed building. So in these buildings, we have to take internal pressure being positive or negative. So we have to take two cases. The design conditions shall be example one with an internal pressure coefficient of plus 0.2 and another with an internal pressure coefficient of minus 0.2. So I'm just again telling you this plus 0.2 indicates 0.2 is the coefficient from internally towards the surface. This is from internally away from the surface. Suppose if we take here, if it acts in this direction, this is towards the surface plus condition. If it acts away from the surface, sorry, if it acts away from the surface, that is negative 1, minus 0.2. Okay, so only same value, but it only with plus condition and minus condition, right? Plus 0.2, one case, minus 0.2, another case. So plus 0.2 and minus 0.2. I'm again telling you plus point is nothing but internally towards the surface, minus point is nothing but internally away from the surface. Okay, so first is pressure. Pressure is nothing but internally away from the surface. So nothing but minus 0.2. All are same. Okay, internal pressure coefficients for all are same. Minus 0.2 I am taking for all. Any surface. Okay. So this is internal pressure. So the net pressure, you'll get one point here. The internal pressure coefficient is algebraically added to the external pressure coefficient and the analysis will be done. Okay. So internal pressure coefficient will be algebraically added to the external pressure coefficients. Algebraically means we have to sum with along with these signs. Whatever the sign convention he has mentioned in the code, we have to use that sign convention, but we have to sum all these coefficients. So plus 0.7 minus 0.2, that gives you plus 0.5. This plus 0.5, you have got plus value here, right? You have got plus value. This plus 0.5 acts towards the surface, right? Acts towards the surface in this direction only, right? So you have got minus 0.2 minus 0.2. So summation got added and you have got the final net value of minus 0.4. This is on B surface, no? So you will get here minus 0.5. This is the surface and away. It is going away. Wind is going away. That's why you have got minus symbol here, minus 0.4. Okay, like that we have to see. This is the pressure case. Okay, let us see suction case. Suction case is nothing but internally towards the surface. Okay, so this is plus 0.2 and plus 0.2 and plus 0.2 plus 0.2. So for pressure case, we have used minus 0.2 for all. For suction case, plus 0.2 for all, as mentioned in the 7.3.2.1 clause in IS 875 part 3. Okay, so here also we will calculate the net coefficient plus 0.7 plus 0.2. You have got plus 0.9. Okay, and minus 0.2 plus 0.2, those will be cancelled and you get 0. Minus 0.5 plus 0.2 plus 0.2, you'll get minus 0.3. Here also same in this case. Okay, so we are using the same coefficients whatever we have got in this table number 5. Whatever we got plus 0.7 minus 0.2 and critical in both these. So we have got minus 0.5. So we are using them as external coefficients here, but we are using it for two cases. Why? Because we have to take internal plus coefficient and internal minus coefficient. Those two are two cases. Okay, so we have got net coefficients like this. Fine. So the same process will be applied for roof also. For roof coefficients, we'll get external wind pressure coefficients in table 6. So let's go to table 6 here. Table 6, right? External pressure coefficients for pitched roofs. Pitched roofs are nothing but gabled roofs, nothing but with some nothing but with some angle upwards. Okay, so those are called pitched roof, like this you are seeing in the code, right? So this is called pitched roof. So again, this is categorized something like this. Okay, so whatever the condition we are getting here. Okay, every pitched roof will be with some angle. Okay, so what is that angle? We'll see. Okay, first of all, let us categorize. Let's go to category. H by W, we have to take H by W ratio. H by W, nothing but height to width. So what is the example? What is the height of in our example? Height in our example, that is 6 meters, divided by what is the width in our example? 20. So we have got height to width as 0.3. So this is less than 1 by 2. 1 by 2 is nothing but 0.5, right? So H by W got 0.3, which is less than 1 by 2. So we have to use first case only, nothing but have to use this case only. Okay. So again, you will get 0 degree wind and 90 degree wind. 0 degree is nothing but along X direction. 90 degrees nothing but perpendicular to the screen. Okay, Z direction. Okay, so X direction and Z direction. Sorry, yes, X direction. If the wind acts in X direction, what will be the roof coefficient here? Okay, if the wind acts in Z direction, what will be the roof coefficient here? So those are 0 degree wind and 90 degree wind here. We'll get. Okay, so and the next criteria we have to see is roof angle A. So what is this roof angle? So I have mentioned here, you can see what is the roof slope I have mentioned. Slope is nothing but 1 by 10, 1 in 10, right? So 1 in 10, nothing but 1 rise in 10 horizontal, right? That is, if 10 numbers, 10 meters horizontal distance is there, we have to use 1 meter rise. That is roof slope. So we have to calculate angle for this. So 1 in 10, right? So tan inverse of 1 by 10, you can calculate. Sorry, just let me calculate from my side. So for 1 in 10 slope, shift tan inverse of 1 by 10. Tan inverse of 1 by 10. What you will get? 5.71 degrees. Okay. So is there anything I can show you here like this? No, in this calculator it is not possible, I think. Right? There are no sign and symbols. Okay, in this calculator it is not possible. You can use your calculators to calculate this one. Okay. Okay, tan inverse, this is 1 by 10, nothing but x by y. Okay, tan inverse of this 1 by 10, you will get angle of 5.71 degrees, right? So 5.71 degrees roof slope. So 5.71 degrees, let us take just as 5 degrees for round figure. For time being, I'm taking that as round figure of 5 degrees. So For 5 degrees, sorry, he has mentioned EF and GH. So what is this EF and GH? Okay, EF is nothing but left side of the roof and GH is nothing but right side of the roof. Suppose I'm showing you in our example. So this is EF, left roof. This is along the ridge. We have to see left of the ridge, right of the ridge. Okay, so this is EF and this is GH. He has mentioned like that. For our convenience, I'm taking it as left and right, left of the roof and right of the roof. I'm taking. Okay. So EF and GH. So what is this EF and GH? For 5 degree wind, this is minus 0.9, right? Minus 0.9. Minus is nothing but away from the surface. Away from the surface. Okay. Away from the surface. We are talking about roof only now. We have completed walls portion. We are talking about roof only. So we have to see these two sections. Okay. Walls are completed. So leave that portion. We are seeing roof only. So left roof and right roof. Okay. For left roof, he has mentioned 0.9 for 5 degree slope, right? 0.9, which is acting away from the surface, externally away from the surface, nothing but towards the outside. Okay. So what is that value? We have got minus 0.9. Okay. So for right side of the roof portion, what is that? EF nothing but GH is nothing but right side of the roof portion. What is the coefficient he has mentioned in the code? Minus 0.4. That thing I'm taking minus 0.4. Okay. Right. Got minus 0.9, minus 0.4. You have got these two values. So like I told you in the I told you in the calculation for walls, the same thing will be applicable here. So we have to take critical from both these cases. For 90 degree wind, we have to take the critical one. Okay, the maximum one we have to take. This is minus 0.8. This is minus 0.4. So minus 0.8 will be critical in this. In these both values, I'm taking minus 0.8 as critical one. So I'm taking the same coefficient minus 0.8 for both. Minus 0.8, minus 0.8. Okay. So again telling you, we are only using 6 cases only. That's why we have to minimize our calculations. That's why I'm not taking other coefficient. Okay, we are taking maximum coefficient mentioned here. Okay, actually theoretically we have to use 8 wind load cases, but in that case in practically we are using everywhere, we are using only 6 cases. That's why I'm taking to minimize the calculation, I'm taking critical of both of these. Okay, critical in both of these. That's why I'm taking minus 0.8, the maximum value, minus 0.8 for both cases. Okay, so these values are same, these values. Okay, because I have to apply pressure, I have to apply suction. Internal coefficient will be vary. Okay, one will be with negative sign, one will be with positive sign. That's why you will get 2 cases here. Okay, but external coefficients will be same in both these cases. Okay, if you observe, external coefficients will be same in both these cases. For walls also, for roofs also, the same thing. Okay, but what you have to change is nothing but you have to use pressure case, you have to use suction case, nothing but signs will be changed, minus plus. The same thing we have to apply concept here. Minus 0.2, minus 0.2 pressure case. Okay, so suction case plus 0.2. So okay, right. Okay, so external pressure coefficient we have taken from table. Internal pressure coefficient we have taken from this class. I have shown you 7321 class. Okay, So we have calculated the net coefficient, nothing but algebraic sum of both these cases, net value. Okay. So minus 0.9 minus 0.2 you'll get minus 1.1. Likewise, minus 0.4 minus 0.2 you'll get minus 0.6, and you'll get minus 1 here, both these cases. Okay. In the suction case, minus 0.9 plus 0.2, you'll get minus 0.1. Minus 0.4 plus 0.2, you'll get minus 0.2 here, and minus 0.6 in this both cases. Okay. So this is how we have to calculate the net wind coefficients for walls as well as roof separately. Okay. Now, how to apply these wind coefficients to a frame? So nothing but our aim is to design a frame in a building. So how to apply these wind coefficients to a frame? So I'm again telling you, these coefficients are for walls and these coefficients are for roof only. Okay. So A and B is nothing but this surface A and this surface B. Okay. So net coefficient will be applied. So 0.5 here, right? A. What is the surface? A surface. Okay. I'm again telling you, A wall, B wall, left roof, right roof. Okay. So A surface, first case. Okay. We have to match pressure to pressure in the roof, pressure in wall to pressure in the roof. We have to match suction in the wall to suction in the roof only. We cannot mix both, right? Okay. Nothing but for suction, we have to take walls. For pressure, we have to take roof. We cannot take like that. Okay, we have to match the coefficients. For either we have to calculate for pressure only, or we have to take suction only. Okay, suppose first case we are saying pressure case. Okay, so A surface is net coefficient plus 0.5. Plus is nothing but towards the surface. You can see one arrow here I am using. Okay, towards the surface, towards the column, nothing but, okay, towards the surface, that is plus 0.5. And this is the B surface, minus 0.4. Minus is nothing but away from the column. Away from the column, nothing but minus 0.4. Okay. And for wall, AB case is completed. So for roof, this one. Okay. So net coefficient is minus 0.1, minus 1.1. That is away from the rafter. So minus 1.1, I'm using one arrow here. You can see one thing I want to tell you, the wind coefficients will be always normal to the surface, nothing but always perpendicular to the surface only. So whatever will be the roof slope, wind will be acting perpendicular to the surface. Okay. So since it is here, the wind acting along this direction, nothing but some inclined y direction. Okay, along with B, some inclination to the y. So whatever the inclination we are providing, 5-degree inclination, let us taken, right? We have taken, that is what inclination we have to take here. Okay, so wind will be acting in that direction in the rafter. So minus 1.1, that is away from the rafter, and left roof we have completed, and right roof minus 0.6. Okay, minus is nothing but away from the rafter. So this is the first case, right? This is the first case. So what is this first case? Okay, wind is flowing from left towards right. So we can call it as wind left to right. Okay, wind left to right, unbalanced condition. Why I am mentioning unbalanced here? So there are two cases we have to see. One is with unbalanced, is with balanced. Or nothing but pressure will be always unbalanced. Why? Pressure will be always unbalanced. So if you observe here, it is suppose this is positive symbol towards the surface externally, internally away from the surface. So in this, both the cases are moving column towards the right side, right? So they are not stabilizing the column. They are both moving the column to the right side. So it is not stabilizing. So that is unbalanced condition. Wind left to right, unbalanced here. Okay. The same thing you can take here. The second case, wind left to right. Now first case we have taken. Now it is right to left. Right to left. Okay. First case we have seen wind is flowing from left to right. Second case, wind is flowing from right to left in this direction. Nothing but this coefficient will come here. Okay. This also acting towards the surface here. This also acting towards the surface here. But wind is flowing left to right from in first case. Wind is flowing from right to left in the second case, right? So these coefficients will be changed. Nothing but if it is in the A surface here, it will come to B surface. Okay. If it is B surface here, it will come to A surface. If, for example, if we take the roof, it is in the left roof because wind is flowing in this direction. Now it is flowing this direction. So the maximum coefficient will be applied here. Okay. This coefficient will come to the right side. This coefficient will go on to the left side. Okay. These are first two cases. In this pressure case, pressure is nothing but unbalanced condition. Okay. So, and the third case is nothing but balanced condition. Why I have used the term balanced condition? So, because if you observe here, okay, this is plus 0.7, nothing but acting towards the surface from externally. Okay. And this is the section. What is the value? What is the symbol here? Plus 0.2. Acting towards the surface also. Internally, it is acting towards the surface. Externally here, internally this side. So it is stabilizing this column. So it will be balanced condition only. So first case we'll see wind left to right. Sorry, third case, wind left to right, balanced condition. Wind left to right, balanced condition. So this is A, surface A, you can see this is surface A, no? So surface A is nothing but this column. Okay. So plus 0.9, plus is nothing but towards the surface. So that's why I'm showing here one arrow towards the column. Okay. And this is 0. There will be no pressure at all on the other column. Okay. 0. It may there will not be any direction because it is 0, but I'm showing just for it, just a case. Okay. So that is 0. And we are using this one now. So we have to take roof coefficients for this only. Okay. So 0.7 minus is nothing but away from the rafter. Okay. Minus is nothing but away from the rafter. That's why I'm going one outside arrow here. Okay. Minus 0.2 here, right side of the roof, minus 0.2. Okay. Away from the rafter on the right side. Okay. So this is wind left to right, balanced condition. So in the fourth case, we'll see wind left to right, sorry, right to left now. Okay, wind right to left. So nothing but in the third case, wind is going in this direction. In this fourth case, wind is going this direction.
Sir.
Yes.
Sir, why it is balanced and upper one is unbalanced?
Sorry, balanced I have mentioned. Okay, this one.
Not clear, sir. Balanced and unbalanced. How? Both the forces are moving the column right side.
Where?
In first case, you are saying 0.5.
Okay, fine. Okay, this is the case you are telling, right?
Yes, sir.
Okay, just I'll explain you. This is external coefficient.
Yeah.
This is internal coefficient. This will be acting outside the building. This will be acting inside the building, right?
Yes, sir.
Okay. So this plus symbol. This have plus symbol. Nothing but it will be acting
Yes, sir.
towards the
Yes, sir.
surface.
Yes, sir.
Okay, just this direction, right?
Hmm.
Okay, so take that. And this is minus 0.2. Internally, it is acting outward of the surface. Okay, for example, if we take this column, it will be in this direction. So both are going in one direction only. This will
Okay,
not
sir.
stabilize the
Okay,
column,
okay.
right?
Okay, sir. Okay.
Understand?
Yes, sir. Yes, sir. Yes. Thank you.
Clear?
Yes, sir. Yes.
Fine. Thank you. And if you have any doubt on this, just okay, feel free to ask me. Okay, no problem at all. I'll explain you if you want once again. Okay, no problem for me. This is yes, wind left to right, balanced condition. Wind right to left. Okay, in the third case, we have seen the wind is going from left side towards the right side. In this case, from right side towards the left side. So this coefficient will come here. In both the cases, it will be acting towards the column. Make sure. Okay, so this is acting towards the column 0.9, but wind is direction this one. In this, wind will be in this direction. So 0.9 here it will come, 0 it will come here. Okay, so roof coefficients also will be exchanged from left to right, right to left. Okay, these are the 4 conditions. Okay, so till now we have seen these are all for 0-degree wind only. Okay, we have seen these are all for 0-degree wind only. We have not used 90-degree wind till now. So 90-degree wind we have to use now. Okay, one is for pressure case, one is for suction case. Okay, so for pressure case, 90-degree wind net coefficient is minus 0.7 away from the surface, nothing but away from the left column. Okay, in the case 5, minus 0.7 away from the, I have shown some arrow here that acts away from the surface, and this one on the B surface also, in the B surface also it is minus 0.7, right? So on the B surface also it is minus 0.7, and for the roof it will be minus 1, minus 1. So here minus is nothing but away from the surface, away from the rafter I am taking, because we are talking about the roof, right? So away from the rafter, minus 1, minus 1. Okay, if we take suction case, okay, minus 0.3, minus 0.3 on A and B surfaces. Minus is nothing but away from the surface, away from the surface 0.3. Okay, and for roof it will be minus 0.6, minus 0.6, nothing but away from the rafter. So these are the 6 wind load cases we are going to use in our design.
Sir, one doubt, sir, here.
Yes.
Sir, in some cases, we will have some wind towards the rafter also. Like, which are the possible cases, sir?
Yes, there are some possible cases wind will be towards the rafter. Suppose, because we are taking one example only here, that's why I have taken this one for time being. If you observe this 7321 or something clause here,
You mean
yes,
where we have
7321. Yes. So these are generally less than 5% openings of wall area is there. We have to use this condition only. Okay. You can see 7322 clause. Okay. Buildings with medium and large openings, nothing but general cases we will use the terminology partially enclosed condition, or large openings, nothing but open conditions. Okay. So in these cases, internal pressure coefficients will be higher, right? In this case, the wind in the wind coefficient on the rafter may act towards the rafter. Okay, if that depends upon openings of the buildings.
Yes, sir. Yes, sir. Got
Fine. If it is less than 5%, this one. If it is 5 to 20, this one. If it is more than 20, 0.7. Okay, that may be depending upon the openings. Fine.
Yes, sir. Yes, sir.
Okay.
But
Sir, also explain page number 12, please.
So
If one side is page number 12, page number 12.
in this only. Okay. Yes. Just zooming out. Okay. Yes. Tell me.
If one side is complete open.
Yeah. Yeah. So what is your correct?
We will follow this coefficient.
No. That here is clearly mentioned. No, that's what I'm telling now. If the openings are less than 5% of the complete wall area, that in that case only we will use this coefficient. Clear?
Okay.
There are some other coefficients as mentioned. If the area of the opening is in between 5 to 20%, internal coefficients will be plus and minus 0.5. So obviously, there are no change in external wind coefficient. First, make sure that there are no change in external wind coefficients. Only internal wind coefficients will be changed. Okay.
Sir, in that diagram, there is some internal coefficient is given.
Yeah.
We will consider that, or the coefficient which is given in table, we will follow that.
Here he has mentioned, okay, buildings with one side openings.
Yeah.
Yes. Yes, tell me.
We will consider this coefficient which is shown in this page, or we will follow the table that we were shown previously.
No. If the wall is completely open on one side, we have to use these coefficients only.
As per direction.
Yes, as per the direction.
Okay, thank you.
So, and make sure that he is mentioning somewhere minus plus symbols. Okay, just make sure that always don't confuse between plus and minus symbols, because instead we are going to use plus symbol and minus symbol differently. But in this case,
Yes.
Nothing but according to the sign convention. Okay, I mean to say sign convention, which is used in this code. Plus is nothing but towards the surface, minus is nothing but away from the surface. Just I'll show you one thing. Okay, okay. Suppose let us take case 2 here. Okay, for example, let us take case 2 here. Okay, suppose what is the difference between applying wind loads in STAD between case 1 and case 2? Okay, here you are getting positive value towards the surface. Positive value is nothing but towards the surface. Here, this is as per the code sign convention only. But in the STAD, while you are applying, this will be positive, because STAD will be always positive towards the right side. In x-axis, STAD will be towards positive towards the right side. In y-axis, positive towards the upper side. In z-axis, positive projection outwards of the screen. Okay, that will be sign convention generally followed in the STAD. Okay, suppose this is positive, you can apply directly in the STAD. In this case, here he is showing positive, but while applying this wind coefficient in the STAD, you have to apply negative, because this is acting minus x direction. That is because STAD will follow general coordinates. Yes.
Sir, will be considered as CPE or CP net. Is it CPE?
Just a minute.
Yes, sir. Page number 12, please.
So,
sir, value say 0.8 plus 0.8. 0.8 is external pressure coefficient or net pressure coefficient?
No. He is using internally, right?
Yes, sir. So
yes.
we will add 0.5 or 0.2 and with negative and positive sign, or 0.8 will be the net pressure coefficient in the case of one wall open.
Sorry, I didn't get it. Come once again, please.
So, sir, 0.8 value is CPE.
No. CPI internal.
0.8 is CPI.
Ah.
0.8 is CPI, but CPI value are only 3, 0.2, 0.5 and 0.7.
Just one thing I want to tell you, there will be no change in the external wind coefficients. Okay, always external wind coefficients are defined in table 5 for walls and table 6 for roof. Okay, and if you see in the diagrams also, just I have not used these cases till now. Okay, probably. Okay, but I am telling you that these coefficients are applying inside. He is showing arrows inside the building. If you observe, arrows showing inside the building. Okay, suppose if they are showing from the outside the building, they can be called as external wind coefficient. But external wind coefficients, if you see here 7.3.2.2 class, external wind coefficients will be always from table. You can see here external wind coefficients will be always something. Okay, pitched roof.
Sir, one more doubt over there.
Yeah.
In this internal pressure is only for when we will apply the wind from open side, right?
What do you mean by an open side? In this one, sir, in page
sir,
number 12.
Please go on page 12.
Yes.
Suppose in first case there is internal pressure is given plus 0.8.
Yes, yeah.
We will consider this internal coefficient only for open side, right?
No. If the wind acts in the open direction, in that case only we have to consider plus 0.8 as internal coefficient.
Yeah. But what if we apply from close side? Which coefficient?
The general coefficients are there, no?
Yeah, we will follow that, no?
Yes.
I was just asking for clarification. Thank you.
Oh, yes. Generally, he is showing here for only special cases. Because all the general cases he has mentioned in the clauses and he has given external pressure coefficients in the table. Okay, these are some special cases. Okay.
Yeah.
Arrows indicate the direction of wind.
Sir, what if all directions are open? I mean, all four side open.
Yes. Okay.
Then
so
it will be 0.8.
Exactly. There is one thing. There will be some. There will not be any internal pressure coefficients.
Okay.
There will not be any internal pressure coefficients. Only external pressure coefficients will be there. Okay.
Okay, sir.
Any other thing? Okay. Let's continue on this. Okay. Sorry. In the meanwhile, okay. All these things are understood, right? How to calculate external. How to see external wind pressure, how to see internal wind pressure coefficient, and how to calculate net, how to calculate them on the, how to use them on the frame. Fine. Okay. Fine. Yeah, if you are all okay with this, just I'm moving to the.
Sir, one more question. Sir, yes, please go on the internal coefficient. External coefficient page number.
Which one? Okay, this one. No? Yes.
Suppose if our given structure is a square in a square shape.
No.
Then
that depends upon this categorizer. He is given.
Sir, please let me complete my question.
Okay.
So in case number 2, the plan is a rectangle.
Which one? Yes.
Is it affect the coefficient? How we decide which side is our A at side?
Okay. Yes. If you see the bottom node here, H is the height to the eaves. Okay. That's why I'm taking U height only always. He has mentioned clearly. And L is the greater horizontal dimension of a building. And W is the lesser horizontal dimension of a building. Right? This thing only you are asking.
Yes.
Fine.
No, I'm asking that square. The building in the plan is shown vertically. Like if we rotate the A, B, C at 90 degree at side, how do we decide that this side is our A at side?
That is what he is telling. No. Okay. Always he will take this as W. Okay. A and B are always along the length. Nothing but he is taking larger dimension as the length and smaller dimension as the width. Okay.
Okay.
Along
Okay.
the length direction, he'll apply A. Okay. Along the larger dimension only, he'll apply A on the one side, B on the other side. You can always see here this case also.
In case of square building, sir.
In case of square building, there will not be any categorization. Why you are asking this question? There will not be any categorization. Directly, in case of square building, it will be one only, no?
No. If you see down, no, sir, you have A, B, C, D. It is a square almost.
Yes.
So how we define A, B, and C?
Okay.
Could be
In that, yes. In that case, I am telling you one thing. Suppose our frame, these A and B always you have to apply on the columns, right? So take this as width. Okay. Frame direction you can take as always width in this case. Don't confuse.
Yes, sir.
Okay, frame direction. Suppose if frame direction is like this, you can say A and B here. Okay. Any other thing?
No, sir. Thank you. Go ahead.
Fine. Okay.
Sir, live load value have been taken 0.6 in your Excel sheet.
Okay. In example.
But yes, sir. But in Indian code, I think minimum live load should be 0.75 when access is given, access is not given, or 1.5 when access is given. So it should be 0.7.
No. I'm taking this as just example.
Okay, sir. Okay.
Okay. No, this is not a project I have done. Okay, this is just I'm taking one example.
Okay, sir. Okay.
Of course, dead load may also be more here. Okay, because
so sir, dead loads will include purlin weight, sheet weight, and
any other collateral load. If customer wants to hang from the roof, that also includes in the dead load itself.
Okay, sir. Okay. Thank you.
Fine. Okay, some customer wants to hang some weights from the ceiling. Okay, that also comes under this dead load only. Okay. Let's move further. Okay, we have completed the load calculation part according to the IS. Okay, and let's move into the ASC section. Okay, because in the course content I have shown you, we are doing project. Suppose I have to discuss projects on both IS and AISC codes. Okay, and also someone has asked me, sir, why you have taken ASC 710 code only? Because ASC 7.5 and 7.10 why I have taken. Okay, I have one reason for that. Although there are some latest codes. Okay, there are ASC 7.16 there is, and ASC 7.22. Okay, 2022 also there. Okay, but these are just coming out of the publications. Okay, generally customer will not have much more idea, because if it is grinding with the time, he'll get some more idea. Okay, that's why suppose we are using 800 2007 version now, because 2000 this is 2022, 2007 is somewhat earlier version. Okay, but why? Because we are using 2007 version. Customer has some idea about that, because it has completed some time and he got some idea what has implemented in that code. That's why. Okay, so with the complete implementation will be done after some time. Okay, that's why we are going some ASC 710, and there is one more reason I'm using 710. The major changes occurred between ASC 7.5 and 7.10 only. Okay. 710 to 722 onwards, there are some minor changes, nothing but according some seismic, suppose for example in ASCE 716, there are some load combination changes in the seismic parameters. Okay, like that there are minor changes only. The major change occurred in ASCE is between 7.5 and 7.10. That's why I have taken that as reference to tell you. Okay. So, for example, I'm taking this as ASC 710 reference because it is some latest version when compared to the ASC 75. So, first let us take how to calculate seismic base shear based on ASC 710. Okay. Or can we see it in the other class, or can I tell you it now? It's completely your wish. I can tell you if you want itself only. Can anyone respond?
Excuse me, sir.
Yes.
Sir, what if we analyze and design using Indian code only? If the section comes over section, or we can say section is not economical, but Indian code design is preferable. Most of the participants are willing to learn this course using Indian code. So
Yes.
why we learn this course using Indian code only? As far as I think, I designed a
yes, you have.
designed a PEB.
Yes, this is some very good question. Some very good question I have to answer. Okay.
Sir, one problem arises. Actually, we did a project and some contractor got the design using AISC, and we had to waited this in MNIT Jaipur. Okay. When we went there, they told me that that they will not wait it using AISC. Please convert in IS Indian 800. Then I converted this whole project in 800, and section increased about 20%. But yes, finally they waited when we convert in Indian code. So if all participants are ready, so we will go for Indian code only in detail. Timing will also, we will save time. And
yes. One thing you have to know, IS 800 discuss about all the steel structures because it has nothing special about a PEB.
Yes, sir. Yes, sir.
Okay. If you see ASCE, okay, it has some design manuals on PEB. Okay, suppose let us take design guide 25. For example, I am telling you design guide 25. If you go through the internet, what is design guide 25? Yeah, you'll get to know. So it has included some PEB applicable topics in the design manual. So nothing but design guide using web tapered members that will give you an economical section where there is no much movement. You can degrade the section where there is heavier movement. You can increase the section.
Yes, sir.
Like that you can do. That is why most of the people in India also are going to the ASE. But just one thing I want to tell you, the design code and load combinations only we have to take from ASE. Okay, but in the seismic weight, suppose we have seen last time seismic base shear. All the things related to seismic and wind. Now we have seen wind coefficients. All these are from Indian code only. Okay. Seismic 1893 load, wind IS 875 load. All these will be applied. But only load combinations and the design. Design is nothing but where we have to check code option is there must add in that check code option. That will be done by ASCE 7 only because it allows web tapered members also.
Okay.
Okay, but the loads and analysis will be done as per the ASCE only. Design will be done as per load combinations as per ASCE in India.
But sir, actually in Rajasthan, some of the people want to get it vetted from amenities. So what is the remedy? They will not accept in AISC. Actually, they want it in IS 800. This is our problem.
Okay,
We
IS
face it two
800,
times.
damn sure you can do, but you'll get slightly uneconomical section. There is
Okay.
no problem in that.
Okay.
Slightly, not much change. Okay, probably you'll get around 10%. No, if you do much more optimization, you get around.
This is my suggestion. Only one suggestion. If all participants are ready to do
yes.
this course with IS 800, then what is wrong? We can.
No. First, First, Indian Civil Engineering Association has to develop, has to see if there is any chance we can do optimization by using web tapped members also. Suppose Indian code will not allow now, but in future it may allow. We cannot tell. Okay. If it has to be done, there will be that will be a great implementation in the future.
Okay.
Sir, to my question, I see most of these PEB companies like they are following this ASC code only. So,
they are not following. They are customer is requesting. No, directly. Sometimes customer will directly contact you. Sometimes consultant. Customer goes to the consultant what he requires, and he'll tell to the consultant, and consultant will call to the company. Yes.
why I am asking, in most of the structures which is made in South India, especially in Hyderabad and Bangalore, where I work, they are all they are seeing for this ASC code only, sir. So if you see,
that's that's completely customer wish. We have to agree with that. We have to satisfy the customer. What customer tells, we have to follow.
Basically, customer doesn't know this coding, no, sir. They generally says that how optimum you will give the structure.
Generally, in that case, consultant will push the client to follow ASC code only.
Sir, a major difference, because I also done many buildings, sir. So I didn't find any building stability point of view. I mean, sir, whatever I done, most of the cases I used the ASC code only.
Yes.
I didn't find any stability point of view or any issues with using this ASC code.
Yes.
No, is there any nothing like that? No, I mean there is no structure.
No. Just I'm telling you again. ASC is some they are using because of economical purpose only. That's it.
There is no compromise on stability.
No. Both compromise on stability. Whether it will be IS 800 or AIC 7, anything may be. Sorry, AISC 360. Anything may be. Both codes will not compromise on stability. Fine. Okay. Something I have got some chart here. Yes, 0.2 constant coefficient only less than 5 or more. Yes, Midun. Midun asked me 0.2 is constant or any other coefficient. Okay, he mean to say just go to class 7.3.2.2. You'll get some more coefficients for different types of openings. 0.8 is critical, and what point for what would we take if value were minus 0.10 and 0.5? Okay, but Rajendra Kumar, you have asked some question regarding external pressure coefficients in 90-degree wind. I think in 90-degree wind, you can take both the cases, no problem at all. But load cases has to be increased. Okay. Suppose we have taken 6 cases only, you have to take 8 load cases, wind load cases.
Yes.
Okay. That if customer allows you more time, you can do, no problem at all. Okay. Half cladding case. What is half cladding? Maybe he is talking about openings, no? just go through the openings clause. Okay, 7.3.2.1. Please explain page number or something. We have discussed all these, no? Design on IS code. Yes, definitely. I'm going to tell you IS code design, and I'm going to tell you AISC design. Both the designs we'll discuss on this. Okay, any other doubts? Because I have to go through seismic calculation, seismic base shear calculation according to ASCE 710. Okay, this is going to take some more time on this. Okay, just we have seen Indian code calculations. Now we have to see American code calculations, and then finally after these calculations, slowly we get moving to frame design and the other components design. Okay, fine, everything is okay, right? So can I end this session now?
Hello, excuse me, sir. I want to question.
Yes, tell me.
Sir, if both end frame are open, what is the internal wind coefficient?
Both end frames are open. You are asking?
Yes, sir. Yes, sir.
Definitely, there is. You need to suppose that depends upon the opening area. Okay. Suppose if the opening is definitely it will not be less than 5%. So we cannot use this point to internal coefficient. You have to check whether it is between 5 to 20% of the opening of the wall. You have to use internal coefficient plus 0.5. If it is more than 20%, okay, plus 0.7.
Okay, sir.
Okay.
Sir, if both end
definitely 7321 clause will not be applicable in that case. 7322 clause only it will be applicable. Yeah, tell me.
Okay, sir.
Fine. So, okay, thank you all of you. Stay safe, and we'll meet again on the next Saturday, sharp 7 p.m. IST. Thank you, one and all. Thank you.